Hey everyone! In this video, I'm going to walk you through how to solve the problems where you have to determine if a coordinate point is in, out, or on a circle. So first, let's review a circle. We have a center and we have a radius. So the radius of that circle is the distance from the center to any point on the circle. Therefore, if any point they give you is on the circle, it will have a distance equal to the radius. Now, if you calculate the distance from the center to that point, and your distance is shorter than the radius, so if it's not quite as long, it's going to end up inside the circle. Then, if you have a point that from the center to that coordinate is further than the distance of the radius, that coordinate would be outside of the circle. So in some of the problems that you'll deal with, they will simply give you the radius. They hand it to you on a silver platter, and then they give you the center of the circle and a coordinate. So your job is to find the distance between the center of the circle and that coordinate and compare it to the radius. Then some of the problems aren't going to give you the radius. They're going to give you the center and a point on the circle. But if that's what they give you, the center and a point on the circle, you can simply calculate the radius. Then you can calculate again the distance from the center to the other point that they give you and determine whether it is inside, outside, or on the circle if the distance is equal to the distance of the radius. So let's do an example. So let's say for an example, they give you a center of a circle at -4, 3, and they give you a point on the circle at 2, -1. And then they ask you the question, is it in, out, or on this coordinate? Let's go with 3, 6. So they give you the center, a coordinate on the circle, and then they ask you the question, is this one inside, outside, or on the circle? So this one is a little bit harder than the ones where they just straight up give you the radius. If they gave us the radius, all I would be concerned with was the distance between the center and my new point. But since we don't know the radius, we have to figure that out first. So I'm going to find the distance from the center to the point on the circle. Now, if you want, you can use the distance formula. So to find the radius, I'm going to do the distance between the center and the point on the circle. So the distance formula is going to be the square root of x2 minus x1 squared plus y2 minus y1 squared. So you could plug in, it won't matter, this isn't like the partitioning problems or the dividing line segment problems where it matters which one you consider x1, y1. It doesn't matter, you can find the distance either way. So you can plug that into the distance formula and get the answer. I don't usually love to do the distance formula. I like to just graph the problem and do Pythagorean theorem. So you can just make a quick little coordinate plane, and I actually don't even make the coordinate plane. If I'm doing it, I can kind of visualize a coordinate plane in my head. So I know the distance from -4 to 2 is 6. I know that's 6 units. So I would just use that as A for the Pythagorean theorem. And I know the distance from 3 to -1. I know that that's 4 units. But if you kind of don't have a coordinate plane in your head, maybe draw one and then just graph everything out. So if you're at -4, 3, you're here. And if you're at 2, -1, you're here. So you could draw that radius, so that distance is the radius. And then you can just count, the slope, basically. And so if you were counting, you would go down 1, 2, 3, 4. And you would go over 1, 2, 3, 4, 5, 6. So then you can use that as 4 squared plus 6 squared equals c squared, which is essentially r squared because that's the radius squared. So this will be 16 plus 36. And if I add those together, I get 52. Is c squared. So I would just say the square root of 52 is C. And you don't even have to get fancy by turning that into a decimal or simplifying it as a square root. I don't know if it can be, but you don't have to do any of that. Just leave it square root of 52. Leave it. Now you have to do the process again using the center and the coordinate you're searching for. So we know that this is the radius. This is kind of what we're comparing it to. So I'm going to work out right here the same thing, but from the center to this point. So I could even make another little coordinate plane. I'm going to be at -4, 3, and at 3, 6. So this would be the distance I'm looking for, and I can find the vertical and horizontal distance. So the way I would do it is I wouldn't even graph it. I would think, okay, how far is it from -4 to 3? Well, I know that that's 7. And how far is it from 3 to 6? That's 3. And then you can go ahead and do Pythagorean theorem again. So it's going to be 9 plus 49. And when you add those together, you get 58. And if you tried to find the square root of it, you would get the square root of 58. So this is the point we're trying to figure out, from the center to this coordinate. Is this distance equal, less than, or greater than the actual radius? So because our point, the square root of 58, is obviously going to be larger than the square root of 52. So that means that this point is going to be larger than the radius, meaning from the center is going to go past where the radius stops. So your point is actually going to be outside of the circle in this case. You could have done the distance formula twice if you prefer not to do the Pythagorean theorem. If you get a number that is less than the radius, you're going to end up saying that it's inside the circle. And if you end up having equivalent values, then your point will be a point on the circle. And I hope you have a great day and that this is helpful. See ya.